Hello everyone. Last time we have taken the line integration. Today we are going to continue the line integration. Last time we have defined the path dependent and path independent integral. So today we are going to check out the example for them. First we are finding the path dependent. If f bar is equal to y square I plus xyj, then find integration from 0 0 to 1 1 f dot dr along the curve C, where first curve C is a straight line joining 0 0 and 1 1, and second curve C is a parabola y is equal to x square. That means we have to find two different line integration as we have given two different curves. So first we are going to start with C is equal to straight line joining 0 0 and 1 1. So if we are going to find out the straight line equation, then it will be x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1. Here your x1 y1 is 0 0 and x2 y2 is equal to 1 1. So putting values, that will give x minus 0 upon 1 minus 0 is equal to y minus 0 upon 1 minus 0, and that will give you x upon 1 is equal to y upon 1 is equal to t, and that will give you x equal to y is equal to t. Now we are going to put all values in r bar. R bar is your position vector xi plus yj plus zk. That will be a ti plus tj, because line is in a xy plane, so the z coordinate will be 0, and therefore dr is equal to dti plus dtj. Now common out dt, that will give I plus j into dt. Same manner f bar is equal to y square I plus xyj. So putting y is equal to t and x is equal to t, that will give you t square I plus t square j, and therefore f dot dr will be t square I plus t square j dot I plus j into dt. So taking dot product, so t square into 1 plus t square into 1, and that will give you 2t square into dt. Now integrating from 0 0 to 1 1 f dot dr is equal to integration from 0 to 1. See, x is equal to t, that's why the limit of x will be the limit of t. So x is a limit from 0 to 1, that's why t also has a limit from 0 to 1. We are going to find the limit of t according to whatever the limit of x or y and whatever the relation we have for in between x, y and t. So here limit is 0 to 1. F dot dr will be 2t square dt. Integrating it, so t square has integration t cube by 3, and putting the limits, then we have answer 2 by 3. C, second equation, C is a parabola, y is equal to x square. So x is equal to t, then y is equal to t square. See, we are going to assume that x is t. Then here if we are going to put x is equal to t, then we have y is equal to t square. So if we are going to put these all values in a position vector r bar, then r bar is equal to xi plus yj plus zk. Again, the parabola lies inside xy plane, so z coordinate will be a 0. X is equal to t, y is equal to t square, and therefore dr is equal to dti plus 2t dtj. Common out dt, and that will give you I plus 2tj dt. Now f bar is equal to y square I plus xyj. Putting y is equal to t square and x is equal to t, we have t square the whole square is equal to t raised to 4 into I. X is t, y is t square, so it will be a t cube into j. And therefore our f dot dr, that will be a t raised to 4I plus t cube j dot I plus 2tj dt. Taking a dot product, so t raised to 4 into 1, that will be a t raised to 4. And t cube into 2t, that will be a 2t raised to 4 into dt. So totally we have 3t raised to 4 dt. And again we are going to integrate from 0 0 to 1 1 f dot dr. Then it will be a integration from 0 to 1, because see, x is equal to t. X is equal to t, and that's why we have a limit of x is from 0 to 1. So t also has a limit from 0 to 1. So 3 into t raised to 4 dt. T raised to 4 has a integration t raised to 5 by 5. And putting the limit, that will give you the answer 3 by 5. Now see, for straight line we have answer 2 by 3, and for parabola we have answer 3 by 5. That's why our line integration is basically depending on a path. Okay, now we are going to check out one example which is not depending on a path. See, for a path independent, we have written two notes. First one, if the curl of f bar is 0, then your line integration is not depending on path. Same manner, if you have f bar is equal to grade f, then also the line integration is not depending on a path. And in that case you have obtained that f dot dr will be a df, where f is nothing but it is a potential function. So we are starting with a second example. If f bar is equal to 2xy plus z cube into I plus x square into j plus 3xz square into k, then show that integration f dot dr is independent of path of integration, and hence find the integral when c is a path joining 1 minus to 1 and 3 1 4. Now first we have to show that the integration is independent of path. So for that we are starting with a curl f. For curl, by definition of curl, we are starting with a determinant of I, j, k, del by del x, del by del y, del by del z. I component of f bar, that is 2xy plus z cube, j component, that is x square, and k component, that is 3xz square. Now simplifying this determinant, so I into del by del y of 3xz square, derivative of 3xz square with respect to y is 0, minus derivative of x square with respect to z is also 0, minus j into derivative of 3xz square with respect to x, that will be 3z square, minus derivative of 2xy plus z cube with respect to z, that will also 3z square, because 2xy has a derivative 0, plus k into derivative of x square with respect to x, that will be 2x, minus derivative of 2xy plus z cube with respect to y, and that will be a 2x, because y has a derivative 1 and z has a derivative 0. So you have 0i plus 0j plus 0k, that means curl f is 0 bar, and that's why your f dot integration is integration f dot dr is path independent. Now we are starting with f bar is equal to grade f, and that implies df or f bar dot dr is equal to df, that we have obtained already in the last lecture. So today we are going to use it directly. So f bar is equal to grade f, so f bar is our 2xy plus z cube I plus x square j plus 3xz square k is equal to definition of grade f is del f by del xi plus del f by del yj plus del f by del z k. Now what we are going to do is we are going to comparing the coefficients both side. That means I component, JJ component and KK component. That will give you del f by del x is equal to 2xy plus z cube. Del f by del y is x square and del f by del z is 3xz square. Integrating equation 1. See, we have to find f from this three equation. So what we are going to do is we are going to integrate equation 1, 2 and 3 with respect to x, y and z partially. Now if you are taking a partial integration, then in that case you have to treat other variable as a constant. So first we are integrating with respect to x. So integration with respect to x. So y and z are treated as a constant. So here x as an integration x square by 2, 2 will be cancelled out and you will have x square into y. Z cube is constant, so z cube into x plus integrating constant. Now see, instead of integrating constant, you have to put some function. Now here the function is of yz. Why it is a function of yz? See, because of basically you are partially integrating with respect to x. So y and z, whenever you have differentiated, at that time y and z as a treated as a constant, and that's why uh, we are taking, instead of simple constant, we have to write down the function of y and z. Same manner, integrating del f by del y is equal to x square with respect to y. So integrating with respect to y, that will give you x square into y plus some function g2 of xz. Same manner, third component del f by del z is equal to 3xz square. We are going to integrate it with respect to z. If you are integrating with respect to z, then z square as an integration z cube upon 3 will be cancelled out and you will have z cube. So x into z cube plus g3 of xy. Now see, what you have to do is you have to using these three, we are going to write down one simple function f. For that, what we have done, we are going to write down one term once. No repetition is allowed. So first one we have x square y plus xz square, that we have written, sorry, xz cube. Here from second one you have x square y, that is already here. From third one you have xz cube, that is also already here. So basically from these three you have a function x square y plus xz cube plus c. Now this is our function. That means you have to write down one term one time, no repetition. From three of all, you have to write down each term without repeating them. Okay. Now putting all values in integration. So now you have to find out the integration from -1 to -1 minus to 1 2 3 1 4 f dot dr. So f dot dr is nothing but that is our df. That theory we have already proved in last lecture. So integration of df will be f and limit will be from 1 minus to 1 to 3 1 4. So f we are going to put the value of f, that is x square y plus xz cube plus c, and limit is from 1 minus to 1 to 3 1 4. So first we are going to put upper limit. So x is 3, y is 1, z is 4. So 3 square is 9 into 1, that will be 9. X is 1, or sorry, x is 3 and z is 4. 4 cube is 64 into 3, that will be a 192 plus c minus x is 1, y is minus 2, that is 1 into minus 2 will be minus 2, x is 1, z is 1, that will be a 1 into 1, that will be 1. And simplifying this term, we have 201 plus c plus 1 minus c. C will be cancelled out and your answer will be 202. So see here it is, your integration is not depending on a path. So you can take any path, then also the answer will be the same 202. It is not depending on path. If you are going to choose any path joining these two points, then also your answer is remaining same. Okay.